Hey there, in this video I'm going to show you how to use matplotlib to make a histogram. So first thing we're going to need is some data to plot. I've already imported NumPy and matplotlib, so you won't see me type that out here, just as it is in your copy of the notebook. I'm going to call my data, and I'm going to use some functions out of NumPy to make random values for us. We'll learn more about using random values out of NumPy in a future lecture, but for now it's just a tool we're going to use. Specifically, I want something called rand_n. It gives me normally distributed random values, a Gaussian in other words. By default, it's centered at 0 with a standard deviation of plus or minus 1. So I'm going to make 100 of these values, and I'm going to scale them up by 100 just so we have some larger values. So this will give me a standard deviation of plus or minus 100. Now I'm going to print out the data just so we can see what we have. And sure enough, we have values that are mostly around 0 with a standard deviation of plus or minus 100. We can have values that are bigger than 100 or bigger than or smaller than negative 100, but the standard deviation should be about 100. I said this is normally distributed, so that's like a Gaussian. And let's make some kind of graph that would show us that distribution. The tool we're going to use is hist out of matplotlib. It gives us a histogram. And the simplest way to use it is to just give it a one-dimensional array. So now when I show it, it's going to create the histogram of values for us. So we can see here it's centered around 0 with a standard deviation of about, well, of exactly 100. And it can tend beyond that. In fact, it looks like we have one value here that's actually really quite negative. Now if you typed in the very same code, these two lines, into your version of the notebook, you're going to get a different shape and a different set of numbers because this is randomized. But you'll get the same kind of overall trend here. Alright, so by default, hist here is going to give me 10 bins. If I hit Shift Tab to get my documentation out, you can see the second argument here is bins. And we have some choices for bins. We can give it just an integer number of bins, or we can give it a sequence saying where we want the bins to start, if you wanted to have fine-grained control. Now normally when you plot a histogram, you want all the bins to be the same size. So it's more likely you'll just give it a number of bins that you want. It's dangerous to make the bins different sizes because visually it'll be very misleading. You can fit more things into a wider bin, but that doesn't necessarily give you the actual shape of the underlying distribution of data. So anyway, by default we're going to get 10 bins. Let's play around with that bin argument to see how things will differ. So I'm going to do plot.histData, and then for bins, let's do a smaller number of bins. We'll do 4. Okay, so now we see our data placed into 4 bins. We could try a larger number of bins. Let's try 40. And we can see increasing the number of bins as it approaches the number of data points will start giving us histograms that don't tell us very much. Like if I had as many bins as data points, most of my bins are only going to have a few things in them. Many of our bins will be empty and I start to no longer see the shape of the distribution. So normally you want the number of bins to be a relatively small number. Let's go back to 4. Another argument we can use in here is to customize the way this looks. We can set the color. So let's make it red instead of blue. And so there we go, histogram with 4 bins, colored red. There are some other arguments here to hist, most of which are just changing the visual appearance, like you can set outlines. If you want a solid line around your data, you can set that. But for the most part, this is the basics of how you make a histogram.